Calculus, an intuitive approach. Episode 1, Why Calculus? What if I told you that there were 4 problems that mathematics simply could not solve? Motion, direction, maximum and minimum, area. These problems gave birth to calculus, and in this series, you're going to understand exactly how. Let's start with the first problem, motion. The 17th century. Modern science is being born. Copernicus and Kepler have just discovered something revolutionary. The Earth moves around the sun. But this discovery raised a profound question. How do objects move? Watch this ball fall. Notice anything? It speeds up as it falls. It doesn't fall at a constant speed. It accelerates. And here's the problem that stumped mathematicians for generations. What is the velocity at a single instant? Think about it. Velocity equals distance divided by time. But at a single instant, how much time has passed? 0. And we cannot divide by 0. So how do you even define instantaneous velocity? This was problem 1. Problem 2, direction. Imagine a cannonball flying through the air. It follows a curved path. As it flies, it's constantly changing direction. At any point on its path, which direction is it heading? If I pick any point, the answer is the direction of the tangent line. The tangent line shows the direction the cannonball is heading at that exact moment. But here's the problem. How do you find the tangent to any curve? This wasn't just abstract mathematics. The invention of the telescope and microscope in that century depended on understanding how light rays bend through lenses. And that required knowing the tangent to curved surfaces. This was problem 2. Problem 3, maximum and minimum. A cannon fires a ball. Depending on the angle of elevation, the ball lands at different distances. Too low, and it doesn't go far. Too high, and it falls short. But somewhere in between, there's an optimal angle that gives the maximum range. Which angle is it? This is what mathematicians call an optimization problem. How do you find the maximum or minimum of a quantity that varies? Simple algebra and geometry couldn't solve this. A new method was needed. Let's pause for a moment and see where we are. 3 problems that mathematics could not solve. 1. Instantaneous velocity. How fast is something moving right now? 2. Tangent lines. Which direction is something heading at this exact moment? 3. Maximum and minimum. What's the optimal value? But there's one more problem, and it's a big one. Problem 4. Area and volume. The Earth is not a perfect sphere. It's slightly flattened at the poles. This shape is called an oblate spheroid. What is its volume? Elementary geometry can handle rectangles easily. Area equals length times width. But what about this? What's the area under a curve? No simple formula works here. The 4th problem, how do you find the area bounded by curves? Euclidean geometry had a method called exhaustion, but it was extremely difficult and limited. A better approach was desperately needed. 4 problems that stumped mathematicians for centuries. Could one mathematical method solve them all? The answer is calculus. The methods that emerged to solve these 4 problems gave humanity the most powerful mathematical tool ever created. As mathematician Morris Klein wrote, "The calculus has proved to be the richest lode that mathematicians have ever struck." So let's lock in what we've learned. Calculus was created to solve 4 fundamental problems. 1. Finding instantaneous rates of change, like velocity. 2. Finding tangent lines, the direction of curves. 3. Finding maximum and minimum values. 4. Finding areas and volumes of curved shapes. In the next episode, we'll tackle the first 2 problems head-on. We'll discover the derivative, the tool that lets us find instantaneous velocity and tangent lines using one powerful idea. And you'll see that it's not nearly as mysterious as it seems. Thanks for watching. Subscribe so you don't miss the next episode, where your journey into calculus truly begins.